What we have done so far were examples of analysis and calculations in the case when the durations of the activities are deterministic. So we know for sure each activity how long it will take. But what happens in the other case? Remember, we called it the probabilistic case, when the activity duration is not certain. It's probabilistic, meaning that it's not unknown, but it's probabilistic, meaning that it can take different values, and we know the probability of each one of these values. It will be defined for us. Okay? So what do we do in this case? We're going to take the case when every activity has 3 time estimates. It can be different, but this is what we are considering in this course. Okay, so every activity, when we are told that it has a probabilistic time, we say we represent this probability by 3 time estimate. What do we mean by 3 time estimate? That means for every activity we will have 3 times. The first one is called an optimistic time, which is the shortest time an activity will take to be completed, right? This is why it's called the optimistic time. Then we have the pessimistic time, which is the other extreme, which is the longest duration the activity can take. And then we have the most likely, okay, which is the most probable duration that the activity will take. How do we get these? In real life, usually you get this by experience. Okay, so the contractor is responsible to do a certain work for you based on his experience, because he has been doing that for a long time. He knows what was his best achievement, optimistic, what was his worst achievement, pessimistic, and what on average how long it was taking him to do a similar work. This is the most likely. This is very important to start your calculations, otherwise we will be stuck. Okay, are there different probability distribution? Yes, of course, but we're dealing now with this case where every activity has 3 time estimates. Okay, like any other variable, x, y, z, whatever, remember that, for example, if you're given a variable x that has a discrete probability distribution, meaning that x can take, let's say, 5 values, 2, 3, 4, 5, 6, and each one of these values has a probability, 0.1, 0.2, 0.3, etc., and the sum is 1. So we can find two metrics for this variable, which summarize or which give us a very good information about the variable, right? The first one is the expected duration, which is a measure of central location, and the second one is the variance of that variable, how these values are spread. So we can do the same for the activity duration. So activity duration is our variable. We can find its expected value, and we will denote that by TE. Okay, as you can see here, it's TE. How do we find it? It's equal to the weighted average of these 4 time estimates, where we give the highest weight, of course, of 4 for the most likely. Why? Because it is the most probable one. And we give only a weight of 1 and 1 for the optimistic and pessimistic. And of course, like any weighted average, you divide by the sum of the weights. This is a given formula. You don't really need to know how did we get that. So this is how you find the expected value, the expected duration of an activity when it's given a 3 time estimate. Then we can find, from that we can find the expected duration of the path. All right, you'll see later why we want to find expected duration of the path, why we want to find the standard deviation of the path. You'll see that. But now let's just focus on how do we find these. As we did in the deterministic case, how did we find the duration of the path? We simply summed up the durations of the activities in that path. Here we do exactly the same, but instead of summing up the activity durations, we are summing up their expected durations, right? Because now every activity has different values, so we will deal only with its expected value. Here we go. So we sum up the expected values of the activities, of all the activities inside that path, right? All right. Then we can find the standard deviation of an activity duration. Remember, our activity duration is a variable, so it has different values, which means I can find its expected value, I can find its variance, standard deviation, which give me very important information. So what's the standard deviation of an activity duration? It's given to us as the difference between the pessimistic and the optimistic, and we divide by 6. Then from that, I can find also the variance of the activity duration. Remember, variance is sigma square. So it's the square of that value that we just showed. So that's why it's equal to Tp minus To squared, and also square the denominator. So it becomes 36. Okay. Mainly, we're not going to use the standard deviation of the activity. We're not going to use that anymore. But just give me some time and I will tell you why not. Then we can find the variance of the path duration. Remember, here also we are dealing now with two variables. With the first variable, call it x, call it w, whatever you want to call it, is the duration of the activity. And then we have another variable, y, which is the duration of the path. Okay, so the path duration variance is equal to what? Since you have the variance of the durations of the activities, you sum up these variances and you get the variance of the path duration itself. So you see this notation, it says summation of the variance of the activities for all the activities that belong to that path, and this gives me the variance of that path. Then from that, I can find the standard deviation. Okay, standard deviation of the path duration, which is, of course, the square root of that. Here we go. Here I have a question for you. Or let me first tell you that I'm going to need this a lot. I'm not going to need the variance, okay, of the path duration. I will need its standard deviation for reasons that I will explain very well later on. But for now, if I need that, and look at the sequence of calculations that we have done, why I simply did not go from here to there by summing up the standard deviations of the activities durations. Why I moved from here to there, and then from here to there, and then from here to there. Why I did not do that shortcut of going from here to there. Why? Because you will see in the next slide. Okay, so brace yourself. And here's the answer. No, you cannot sum up the standard deviations. Okay, because the standard deviation is a kind of metric that cannot be summed up. If you need to do some summing for a measure of variability, you have to add up the variances. Yes, you can add up variances, but not standard deviation. So never do this mistake. If you want to find the standard deviation of the path, what you have to do is to find the variances of the activities, sum up the variances of these activities so that you can get the variance of the path, and then you square root that and you get the standard deviation that you want.